Hello, this is Miss Van Human here, and today you guys are going to be doing a workshop on compound interest. So your learning intentions for today, we are learning to calculate compound interest, and this is so that we can apply our understanding of financial maths to everyday life, such as future bank accounts that you guys will have or you already might have, but just don't know what the type of interest is. By the end of today's lesson, you guys will have completed workshop notes with worked examples from this PowerPoint slide, and you may have an opportunity to start the skills practice, which is exercise 3F. Now, what you should have in front of you is, so you should have your laptop with headphones to start watching this video, but you should also have printed off the workshop's examples sitting next to you. So you just have to copy the working out, and you shouldn't be writing out any of the questions. If you don't have that, please ask the teacher in front of you. Otherwise, if you go to Compass to our class page, along the tabs where you can see learning tasks, there's also a tab that says resources. You can pause this video and go to that resources tab now for our Year 9 Extension Maths class page and print off a sheet that says compound interest example page, and you can then just copy down the working out onto that. Okay, so do that now if you haven't, otherwise let's get started. So let's have a quick review of what is interest. So remember that banks pay interest on money that savers invest with them, which is the principal, and they also charge interest on money that is borrowed from them. So remember, the reason that they give us interest is because they don't leave our money sitting there in the bank like Gringotts at Hogwarts. They go and invest it in shares and make money off that. So to say thank you for leaving that money in the bank, because they're going to make more money on it, they give us some interest. And it's exactly the same with a loan. They're doing us a favor, so we pay them back interest on that loan. Interest is given as a percentage, and there are two types, simple and compound. Now, we've talked about simple interest being the interest on what you originally invest in the bank, and you only get that same interest again and again and again. So it's not what you have in the bank, it's what you deposit in that original amount. And have a look at those notes if you have forgotten that. Whereas with compound interest, let's have a look at an example to help us understand that. Just say we have a principal of $1,000 that we put in the bank, and the interest rate is 10%. Now that's a really high interest rate, but it's just easy for me to work out in my head. So with this, after the first term, we get a 10% interest on that $1,000. So 10% of 1,000 is 100. So we'll end up with $1,100 after that first term, whatever that might be. Next term, we get another 10%, but this time it's on that $1,100, not the original 1,000. So 10% of 1,100 is 110. So you'll see that we've now got 1,210. For the next term, we'll get 10% of $1,210, which is 121, which means we'll then have $1,331 in the bank. So you can see here that our interest that we get is much better than simple interest, because we are getting paid interest on what is in the bank at that time, which is more and more and more, not that smaller original amount that we started off with. Okay, so this part here you need to copy down in your book, so make sure you've got the page ruled and you write down the heading Workshop 6, Compound Interest. So let's start off with a definition. Compound interest is the interest paid on the money invested and any interest that is earned on that money, i.e. the current balance of that bank account. It's helpful if we have an example to have a look at here. So $10,000 is invested at an interest rate of 7% compounded annually. The interest is calculated each year on the new balance. The new balance is obtained by adding 7% of the balance of the previous year. Therefore, after 4 years, we want to work out 110%, because we have that 10,000 plus 7% more, so we're increasing that by 7%. So you can see here 100%, 107% increase is the same as 1.07, but that's after 1 year. So if we'd like 2 years, we're going to times it by another 1.07, 3 years and 4 years. Now, as you can see here, this repeated multiplication is going to take quite a long time to write down. For example, if we had a question that went for 12 years. What we can do is simplify that repeated multiplication of that percentage increase to using index notation. So we end up here with 10,000 times 1.07 to the power of 4, which gives us a total value of $13,107.96. Now what we're going to do is use a formula here based on that second line of working out to shortcut us writing out that repeated multiplication there. It's really important to point out here that with compound interest, this amount that we're talking about, this $13,107, that is the interest and the principal that was invested in the start, compared to the simple interest formula that only calculated the simple interest. And if we wanted the total amount, then we then had to add on that investment. Okay, so let's have a look at the compound interest formula. Again, you need to copy this down in your books. So we have the amount, which we spoke about being the principal and the compound interest. Again, P stands for the principal, which is the amount saved or borrowed in some questions. We then have 1 plus the interest rate, and then it's to the power of the term, so the number of years there. Again, when you're using this formula, the interest rate needs to be converted from a percentage to a decimal. Okay, so example 1, again, you should be just doing the working out on that sheet that you've been provided. So in this question, Gail has invested $100,000 for 6 years with Mountain Bank. The bank pays her interest at the rate of 7.5% per annum, which is compounded annually. How much will the investment be worth at the end of, and we'll sort that out in a second. So keywords to highlight here is $100,000. It's for 6 years as our term, and we have a 7.5% interest rate, and we know that this is a compound interest question because it says that it's compounded annually. So we want to find out what it's worth at the end of 1 year, 2 years, 6 years, and then what is the percentage increase on her original investment in the end of 6 years. So to 2 decimal places. So for 1 year, I'm going to highlight that as well, just because that's our term for this question. Now, just while you're learning to work this out, we're going to write out our formula as the first step. So we know that the compound interest amount is the principal multiplied by 1 plus the rate as a decimal to the power of term. So here, for this question, we're simply going to sub in our values. So our principal is 100,000. And we're going to multiply that by 1 plus 0.075, and that's to the power of 1, or we don't need to write that there because to the power of 1 is just exactly the same as that number. Entering that into your calculator, you'll end up with $107,500 there. Okay, let's have a look at part B. So 2 years, we're going to be using exactly the same formula, but this time it's to the power of 2 because we've got 2 years. Entering that into our calculator, and you'll end up with $115,562.50. Neither of those two answers I've had to round. Okay, 6 years. Same formula, but this time to the power of 6. So put that in your calculator and pause the video and see if you can work out the answer. And you should have got $154,330.1526. Now, knowing that we're dealing with money here, it doesn't specify how many decimal places to go to, but it makes sense to go to 2. So I'm going to approximate that answer there just to those 2 decimal places. So we have 15 cents. The final question, part D, says what is the percentage increase on her original investment at the end of 6 years? Now, there's 2 ways to work this out. So for the moment, I'd just like you to listen and I'll talk you through both steps, and then you can choose which step to copy down, or you might like to copy down both. Remember, there's lots of different ways to do things in financial maths, and you need to pick the way that makes sense to you the most. So the first way to do it is to work out what the percentage increase is, and then divide that by the original amount, times it by 100, and that will give you the increase. So subtracting what we started off with to what we've got now at the end of the 6 years gives us an interest of $54,330.1526. You'll notice I haven't used the rounded answer here because that is the most exact answer, and rounding it off might have an impact there. Okay, so I'm dividing it by the original, multiplying it by 100 to get it as a percentage, and then I've rounded off my percentage to 2 decimal places, which is a 54.33% increase. Now, the other way to work this out is exactly how we were doing for the last exercise on repeated percentage increases or decreases, which is just multiplying what we're increasing by. So that 1.076 to the power of 6, which gives us 1.543301. Now, because this answer is greater than 1, it's 0.543301 greater than 1. We've had a 54.33% increase. Okay, remember, if it's lower than 1, then that drop, that below that 1, that's the decrease that's happened. So 2 different ways to work it out. You can pause the video now and decide which way you would like to solve these sorts of problems that you'll be faced in the text. Okay, part E says, what is the total interest earned over the 6 years? We just worked that out in the previous part using the first method. So we have the final amount. Remember, that includes the compound interest and the investment. And so we end up with that $54,330.15. That's the answer to that part. And F says, what would the simple interest on the investment have been, assuming the same interest rate and time, obviously at 7.5% per annum. So again, just while we're getting to know this, I'm going to write out my simple interest formula of the principal times the rate times the term. I'm substituting in those values, so I've got a principal of 100,000 times 0.075 times 6 years gives us an interest of 45,000. So looking at part E and F, which is the better interest? Obviously, compound interest there. It's 9,000 more. Okay, example 2. Hussein is setting up a plumbing business and needs to borrow $150,000 from the bank to buy a truck and other equipment. The bank will charge him interest of 11% per annum, which is compounded annually, and Hussein will pay the whole loan off all at once after 4 years later. How much will Hussein owe the bank at the end of? And we're going to look at these amounts. Now, this problem here is an example of a loan, and the exact same principles apply with a formula when we're having to borrow money with a loan as well as investing it. So this is one of those examples. So we're looking at 2 years and 4 years here. So again, we're going to highlight those key values. So the 150,000 there, the 11% that's compounded annually, 4 years, and we're also looking at 2 years for part A. So we've got our formula. We're going to substitute in our principal of 150,000, add that interest rate to 1, and then put it to the power of 2 because it's 2 years for part A, and that gives us a result of $184,815. Okay, part B says 4 years. So have a think about what this is going to look like. What's it going to be to the power of this time? Again, that's to the power of 4. Put that into your calculator. Whoops, sorry. And you should have got $227,710, and then rounding it to 2 decimal places there, as that makes sense because we're dealing with money. Okay. Part C says, what is the percentage increase in the money owed at the end of the 4 years? So the key part here is, what is the percentage increase? Now I'm going to use that repeated percentage increase and decrease method. I'm going to times that percentage increase, or put it to the power of 4. this means that it's going to be, remember, I've got 0.51807 more than 1, so we've got a 51.81% increase there. Part D says, what is the total interest that Hussein will pay on the loan? So we need to find out how much more he's paying off than what we started with. So he's having to pay back $227,710.56 minus the $150,000 that he's borrowed gives us $77,710.56 that he is paying back in interest. And again, part E says, what would the simple interest be on the loan? So again, I'm going to write out my formula, sub in my values. So you can pause the video at any stage and have a go at any of these questions yourself. Okay, so we've got the principal, the rate as a decimal, and then the term. Entering that into your calculator gives $66,000 would have been the simple interest on that same loan. Okay, final example. Alini wants to borrow money for 3 years to start a business and then pay all the money back with interest. At the end of that time, the bank will not allow her final debt, including interest, to exceed $300,000. Interest is 9% per annum compounded annually. What is the maximum amount of money that Alini can borrow? So again, we're looking at that loan style question, but there's one big difference with this problem here. So let's start highlighting the key terms and see if you can work that out. Okay, so we know that we don't want the money to exceed 300,000. So 3 years is the term. We've got an interest rate of 9% and we know that it's compounded annually. And I wonder if you've picked up those other two keywords here. So the maximum amount that Alini wants to borrow is is what we're trying to find out. So what we're wanting to find out in this problem is, what does she need to start out with? What is the original amount if the final debt cannot exceed 300,000? So we don't know how much Alini wants to borrow. That's what the question is asking us to find out, given that the final debt cannot be any more than 300,000, and that includes all the interest that she has to pay along. So we want to find the original amount and what to start out with and borrow. So remember, when we have a question where we want to find the original amount, this is where we reverse the process and we divide. So we're using the exact same formula, but instead of multiplying, we're dividing to reverse it to go back to the original amount. So subbing in those values, the final amount is 300,000, and then we're dividing by 1 plus that 9%, which goes in as a decimal, and it's a 3-year term, so we've put that in there. Entering that into your calculator gets this as an exact answer, so $231,655.044, and then rounding it to 2 decimal places there. So what we have worked out here is what Alini can borrow. So she needs to take out a loan, no more. This is her maximum amount of $231,655.04. So that when she has to pay everything back at the end of the 3 years, it is no more than 300,000 at the end. Okay, so that is the end of our workshop today. If you have any questions at all, we will go over those in class tomorrow. Please make sure you have copied down all the working out. So everything that's blue in the slideshow, you'll see that that's what you need to write down onto that sheet and copy down. And you can now begin the compound interest textbook questions. Best of luck.